Hello and welcome to Engineers Mindset Academy. So we've been doing a whole lot of series involving thermodynamics and how to calculate work done on a given system or work done by a system in thermodynamics. Alright, so let's consider this other question on the board. The question says fluid at 10 bar is contained in a cylinder behind a piston. The initial volume being 0.05 meter cube. Question says calculate the work done by the fluid when it expands reversibly according to the linear law to a final volume of 0.2 meter cube and a final pressure of 2 bar. So let's pick out our parameters. First of all, we consider the conditions at state 1. Okay, at state 1 we have fluid at 10 bar, which means initial pressure P1 equals 10 bar. Okay, is contained in a cylinder behind a piston, the initial volume being 0.05 meter cube. So initial volume V1 is equal to 0.05 meters cube. Okay, now we consider the condition at state 2. At state 2, we consider the condition. Calculate the work done by the fluid when it expands reversibly according to the linear law to a final volume. So V2 is equal to a final volume of 0.2 meters cube and final pressure P2 is equal to 2 bar. Okay, so not forgetting, we always convert our pressure to Pascal. So P1, which is 10 bar, is actually 10 by 10 to the power of 5 newtons per meter squared, and P2, which is 2 bar, is 2 by 10 to the power of 5 newtons per meter squared. Always learn to convert your pressure to Pascal. Now it says it expands according to the linear law. The linear law is simply given as, okay, linear law is simply given as P equals KV plus C. Now this was actually carved out from the equation of a straight line. Okay, it was carved out from the equation of a straight line, which is represented as y equals mx plus c, where m is the slope and c is the intercept. Of course, where y is the dependent variable and x is the independent variable. So that is where the linear law was actually carved out from, the equation on a straight line. So P for pressure equals KV plus C, where K and C are simply what? Constants. So we need to, as usual, find the values of a constant before we can be able to use the pressure equation to solve for our work done. All right. So if this is our linear law, then this simply means that P1 is simply equal to K V1 plus C. So like I said, V and C are all constants. It also means that P2 is equal to K V2 plus C. Again, K and C are what? Constants. So we simply relate these conditions to find the value of K and C. Considering for P1 was given as 10 bar, which is 10 by 10 to the power of 5. So we have 10 by 10 to the power of 5 is equal to KV1, and V1 was given as 0.05. So we have 0.05 times K, that gives us 0.05 K plus C. So you can simply call this equation 1. Whereas for P2 was given as 2 bar, which is 2 by 10 to the power of 5. So we have 2 by 10 to the power of 5 equals KV2, and V2 was given as 0.2, which is the second volume. So we have 0.2 times K plus C. Call this equation 2. Alright, so now we have two simultaneous equations, and you can use any approach to solve this, but the best approach in this case now is to use the elimination method, simply because here C does not contain any coefficient attached to it, so you can simply eliminate C by subtracting equation 2 from equation 1 or subtracting equation 1 from equation 2. Alright, so let's subtract equation 2 from equation 1. So we simply subtract these two equations, subtracting 2 from 1. So I have 10 by 10 to the power of 5 minus 2 by 10 to the power of 5, and this will be equal to, I have there 0.05k minus 0.2k, okay, plus here I have c minus c. Okay, now 10 by 10 to the power of 5 minus 2 by 10 to the power of 5 gives us 8 by 10 to the power of 5, and this is equal to 0.05k minus 0.2k. 0.05k minus 0.2k gives us minus 0.15k. Okay, now c minus c is off, that's 0, so I'm simply left with this. Now I can divide both sides by minus 0.15 to find the value of k. So this simply implies that k is equal to 8 by 10 to the power of 5 divides minus 0.15, and as such we can find the value of k to simply be, let's find this division now. So this gives the value of k to be minus 5, 3, 3, 3, 3, 3, 3. Alright, so this is approximately the value of k. Now, if you know this to be the value of k, you can substitute this value into any of the equation to find the value of c. So let's say we are putting this value into equation 2 to find the value of c. Alright, substitute k into equation 2. Okay, so if we do that, equation 2 we have 2 by 10 to the power of 5, and this is equal to 0.2k. Now in place of k we put in this value minus 5, 3, 3, 3, 3, 3, 3. Okay, plus c. All right, so 2 by 10 to the power of 5 is now equal to, let's expand now, 0.2 multiplies this value. That gives us minus 106,666,6. Alright, so 2 by 10 to the power of 5 is now equal to, now we multiply 0.2 by 5, 333, 333. That will simply give us minus, not forgetting there's a minus sign there, 10, 666, 66.6. Okay, 66.6 plus c. You put down your c. Alright, so in order to find the value of c, simply send minus 10, 666.6 over to this side of the equation. Negative sign cross an equal to sign becomes positive. Therefore, you're going to obtain that c is equal to, we have 2 by 10 to the power of 5. It becomes plus 10, 666, 66.6. Alright, so let's find this value. This simply implies that the value of c is equal to, so we simply add that value to 2 by 10 to the power of 5. So that simply gives us 126,666.6. Okay, 666.6. Alright, so you have to be very careful with these calculations. Okay. Alright, so that's it. So now we have the values of k and the values of c. We cannot plug it back into the law. The law becomes, okay, the law becomes P equals, remember we said kV plus C, and we know the value of k. K is simply equal to minus 5, 333, 333. So we'll put it down, minus 5, 3, 3, 3, 3, 3, 3, V plus C. And C is simply this, 1, 2, 6, 6, 6, 6, 6.6. Okay, so this becomes the law. So let's just rearrange a little bit. Since this is negative, bring the positive over here. So this simply implies that P is equal to 126, 666, 66.6 minus 5, 3, 3, 3, 3, 3, 3, V. Alright, so this becomes our law. Now, you recall that work done is equal to the integral from V1 to V2 of P times dV. This is the formula for work done. Therefore, work done is equal to integral V1. What is V1 from the question? V1 was given as 0.05 and V2 was given as 0.2. So we effect those values there. So integral from 0.05 to 0.2 of P dV, and this remains our pressure 12666.6, okay, minus 5333333 V times dV. We simply have this. Now, from the rule of integration, the difference of an integral is simply the integral of the difference. So, since I have the difference of this integral, it simply means the integral of each of these words function and they are different. So, it means use the integral sign to simply expand the bracket. That's all I'm saying. So, work done is equal to, if I use this integral sign to expand this bracket, I will simply have integral from 0.05 to 0.2 of 12666.6 times dV minus, again, use the integral to expand the second term there. I will have integral from 0.05 to 0.2 of 5333333 V times dV. I simply have this. Now, from the rule of integration, always pull out a constant term out of the integral sign. So these numbers are constant terms, same thing as these numbers. Pull them out of the integral sign. And if we do that, we are going to have that work done is equal to 12666.6 integral from 0.05 to 0.2. I'm now left with dV over here for the first case. I'm left now with dV, which is this, minus, now pull out these numbers, 5333333 integral from 0.05 to 0.2. I am now left with what? V times dV. So I have V dV over here. So that simply gives us the work done. Okay, let's continue here. All right, so the work done, W, is now equal to, if I integrate the V, I will simply have V. Okay, integrating the V, I will simply have V. So let's put down the values. I have 12666.6. Now into integrating the V, I will simply have V. Put in your limit 0.05 to 0.2 minus, now you put down the second number, 5333333, integrate V. If I integrate V from the rule of integration, I will simply have V squared all over 2. Put in your limit from 0.05 to 0.2 and you have that. All right, so this is equal to 12666.6 into V into 0.05, 0.2 minus, now let's pull out these two so that I will have only V left in the bracket. This gives me 5333333 divides by 2 into, I'm now left with V squared. Put in your limit 0.05 to 0.2. Okay, so work done is equal to 12666.6 into V. So mind you, I am not putting the limit yet. I want everything to be sorted out before putting the limit all together. All right, so from 0.05 to 0.2 minus, so let's obtain 5333333 divided by 2. Let's obtain the value. That simply gives us 2666.5 into V squared from 0.05 down to 0.2. All right. So at this point now, having sorted out these parts, the next thing now is to effect the limit. So always upper limit minus lower limit. So work done is equal to 12666 66.6 into, in place of V, upper limit minus lower limit. So we start with 0.2 minus 0.05, okay, minus, over here we have 666.5 into, mind you, this is V squared. So it means it's going to be upper limit squared minus lower limit squared. So this becomes 0.2 all squared minus 0.05 all squared, okay, minus 0.05 all squared, and we have that. So this is equal to 12666.6 into, let's now obtain 0.2 minus 0.05, that gives us 0.15 minus 2666.5 into, let's obtain now 0.2 squared minus 0.05 squared. That gives us 0.0375, and we have this. So work done is equal to, let's now obtain 12666.6 multiply 0.15. That gives us approximately 190,000, okay, minus, let's now obtain 666.5 multiply 0.0375. That gives us approximately 100,000, okay, that gives us approximately 100,000. Now this implies that work done is equal to 190,000 minus 100,000. That will give us approximately 90,000 joules. So this is the work done, or you can simply also call this 90 kilojoules. All right, so this is the work done for that given question. Once again, the question says calculate the work done by the fluid when it expands reversibly. So it underwent an expansion process, and I've already told us in the sign convention that when a system undergoes an expansion process, then the work done is positive. Now I'm going to post all the links to the calculations right from the introduction video and down to all the calculations we've done in other videos on the description of this video, so you can properly watch all of them together for proper understanding. But this is the value, or this is the value of the work done for that given system. Now, before I move on, you can actually employ a shortcut to solving this same problem, but the shortcut can only be used when the law is a linear law, because this question has told us that the fluid expands according to the linear law. So you can apply a shortcut to solving this problem if the law is a linear law. That shortcut is by using the PV diagram. So I'm just going to show a rough sketch of using the PV diagram to solving this problem in less than 5 minutes, and you're going to arrive at this same answer without going through this whole rigorous exercise. But it must be under a linear law condition. So let's make out a space and use the PV diagram to solve this same problem and see. All right, so from the PV diagram, you have something like this. This is the pressure, and this is the volume. I always say pressure takes the vertical line, volume takes the horizontal line. So let's take out the parameters from the question. At state 1, pressure is 10 bar and volume is 0.05. So at state 1, we have our pressure to be 10 bar, okay, and which you can always convert. So this is 10 by 10 to the power of 5 in newtons per meter squared, or simply Pascal. And the volume then is 0.05 in meters cube. At stage 2, the pressure drops to 2 bar, the volume is 0.2. Okay, at stage 2, pressure is 2 bar, which is 2 by 10 to the power of 5, and the volume is 0.2 meters cube. So let's relate them. The first pressure to the first volume, this is where they meet. Second pressure, okay, second pressure to second volume, this is where they meet. And since it is a linear law, it means we are going to be having a straight line graph, something like this. Okay, something like this. Yeah, we are going to be having a straight line graph, something like that, since it is a linear law. All right. Now, to find the work done is simply the area under the shaded region. The area under the shaded region gives us the work done. It's as simple as this. And now, what is the area under the shaded region? We have this to be a triangle and we have this to be a rectangle. So the first part is a triangle, whereas the second part under here is a rectangle. This simply implies that work done is equal to the area of the triangle plus the area of the rectangle. The area of the triangle plus the area of the rectangle gives us the work done. Now, how do we find this? Okay, we know that area of a triangle, so I'm using a subscript t for area of a triangle, is always half base times height. So the half times the base of the triangle times the height of the triangle. If this is the triangle, then what is the height? Height is simply from here to this point. If from here, this is the origin, 0. If from 0 to this point is 2 by 10 to the power of 5, and from 0 to this maximum point is 10 by 10 to the power of 5. What is now from here to this point? To obtain from this point to this point, if from 0 to this point is 10 by 10 to the power of 5, then this height alone, the height of the triangle alone, simply means removing 2 by 10 to the power of 5 from 10 by 10 to the power of 5. Okay, that will give us this height. And if we do that, 10 by 10 to the power of 5 minus 2 by 10 to the power of 5 simply gives us 8 by 10 to the power of 5. So this remains the height of the triangle, whereas the base is from here to this point alone. So if from 0 to this point is 0.2 for the volume, and from 0 to this point is 0.05, that means from this point alone to this point, to get the base of the triangle, simply means to move 0.05 from 0.2. So it becomes 0.2 minus 0.05, and that will give us 0.15 meters cubed. So this becomes the base of the triangle. So the area of the triangle is simply what? Half base is 0.15 by height, and height is 8 by 10 to the power of 5. This simply implies that the area of a triangle is equal to, let's multiply this through 1 all over 2 times 0.15 times 8 exponential 5. That simply gives us 60,000. So we have 60,000. Okay, we have 60,000 to be the area. Keeping this aside, then we move to the rectangle. The area of a rectangle, let's simply call that A arrow. So I'm using A for area, arrow for rectangle. This is equal to the length times the width. The area of a rectangle is simply the length times the width, and this is equal to the length of the rectangle is simply from here to this point, which measures 0.15. So we have 0.15 times the width is the measure of the thickness from here to this point. This is where the rectangle actually ended. So the width is the measure of the thickness of the rectangle, which is from here to this point, which is from 0 to where? 2 by 10 to the power of 5. So the width is actually 2 by 10 to the power of 5. So 0.15 multiplies 2 by 10 to the power of 5. And if you multiply this through, okay, if you multiply this through, you're going to have 0.15 by 10 to the power of 0.15 multiplies 2 by 10 to the power of 5. You're going to have 30,000. Okay, it's going to give you 30,000. And we said the work done is the sum of the area under the shaded region. So the sum of the area of triangle and the area of the rectangle gives you the work done. Therefore, work done is equal to area of triangle gave us 60,000. So we have 60,000 plus area of rectangle gave us 30,000. So we have 30,000. And if you add these two all up, it still gives you 90,000 joules, which is the same answer as what we obtained using the main formula. All right, so you can also solve this problem using the PV diagram only if it is a linear law. But if it is not a linear law, it means you cannot solve. All right, guys, so that's it on this particular question. In the next video, I will see you with one more question now that has to talk about compression and we'll wrap it up on work done in thermodynamics. Thanks and cheers.